Welcome to qnawire.
Okay, so what we have here are two adults pushing on a cart, and they want the cart to move to the right. However, they're both exerting diagonal forces on that cart. And we're going to call those F1, F2, being exerted at angles theta 1 and theta 2, respectively. And the question is, what third force would a child have to exert? What is the smallest force that a child would have to exert to make the cart only move purely horizontally to the right? And so in order to do that, we just need to balance all the forces in the vertical direction. So in other words, just to start off, we just need to tally up all the forces in their vertical direction. So we're going to call that the y component. So we'll just set up a typical Cartesian axis right here. And then the total y component is going to be equal to the sum of the y components of our two constituent forces, F1y and F2y. So doing a little bit of trigonometry on that, we see that this is the sine component of each of these two vectors. However, we need the negative component of F2 because it's pointing downward. So now we can plug in some numbers, namely 100 times sine of 60 degrees, and then subtracting off 140 of sine of 30 degrees. In order to get that the total net y component is 16.6 newtons. Which tells us that the fictitious third additional force we would have to add is the magnitude of 16.6 newtons, but is directed downward. So in the negative y hat direction. This is how much the child would have to exert in order to cancel out that vertical force, so that we're only left over with a purely horizontal force. So that's part A. Part B is asking us what is the mass of the cart if it has an acceleration of 2 meters per square second, and then also what is the weight of the cart. So we just have to multiply that by the acceleration due to gravity. So this will involve a similar Newton's second law calculation, but this time for the x direction instead of the y direction. So we need to add up the x components from each of those two vectors. So this will be the cosines via process of elimination instead of the sine components. And then the forces are working together in this problem, so it will be, they'll both be positive. So now we can add those together like we did before. Same numbers. Cosine of 30 degrees, not theta 2. Plug this into the calculator, and we get 171 newtons is the net force that we're acting on in that direction. Now we can use a little Newton's second law in order to find the mass of the car, because we do know its acceleration in the x direction. 171 divided by 2 will give us a mass of 85.6 kilograms. Then I'm just going to do one last little calculation to find the weight and multiply that by the acceleration due to gravity. It's 85.6 multiplied by 9.81 meters per square second. So it's supposed to be a 1. And then at the end of the day, I get 840 newtons is the weight of that cart. Alrighty, and we are done.